Being recorded. Let's see. I'm only missing about 20 some odd people.
Okay. All right. If I have any more, I'll let you know if I have any more questions.
Yeah. So yeah, anybody have any questions? Yeah, what's going on? So we do have tomorrow off. Do you guys? I think I mentioned that briefly, but you know, if you look at the link for class this week, it doesn't include one for tomorrow because I have a meeting tomorrow and then I have a meeting a week from tomorrow. Yeah, so I think we could take a day off each week, next 2 weeks, to decompress from Zoom. That sounds fine. Anybody, any questions?
I had a question.
Yes.
Number 6 on 3.5 on the page 358.
Oh, yeah. So this is going back in time a little bit for us. So there's two parts to the question, right?
Mm-hmm.
All right. So like if you write 10.5 ounces of gold, can you convert that to money? Right? 10.5 ounces of gold. So let me write that. Can you put the conversion you got in number 5 in the right way here to convert from ounces to money? That's all it's saying, right? So what would go on the bottom? What units? Does that make sense?
Ounces?
I mean,
yes, ounces.
Yeah, ounces. I love it. And then on top it go dollars, and then you just put the right numbers in the right place.
Okay, and that's all you do for that one?
Yeah, and then this is the other way around. You start with $30,000. So now you know it's got to be on the bottom, it's got to be on the top, and you put the numbers in the right place. So it's just reminding you about conversions.
Okay.
That's all. Because the what do you call it? The direct variation stuff, very often you can look at it as conversion problems.
Mm-hmm. Okay.
So that's why they want you to remember conversion stuff. Yeah.
Awesome.
All right.
Thank you.
You're welcome. Anyone else? Questions? I'm a little concerned because there are some interesting questions in like section 3.5, for example, but I think we looked at the tile problem and all that. So maybe it's not that bad. Maybe everything's fine. I'll be optimistic. All right, I'm going to clear all this away. Go away. All right. So let's see, I'm finally using some more functionality of this thing. There we go. Let's see. If there's no questions, I'm going to jump right into a little bit of a review. Oops. Did I just mute somebody? Everybody all right out there? Any questions? Okay. So let's look at these problems here. This is out of the review section for chapter 3. Go ahead and try to do the first couple of these problems here. All right, do a few of these, and then I'll come in and catch up to you here in a minute. Does everybody have a plan for voting? Has anybody already voted? I voted. And I saw, it's really nice when you get the notification saying your vote will be counted. I'm like, oh, good. That's always good. I got really paranoid about my signature matching on my ballot, but it sounds like it's all good. So if you're just joining us, if you could please start trying these problems out. If you have your book, it's page 449, starting at number 28. Please try these problems out. Uh-oh. Number 30, you got to be a little careful. All right. Number 28 is kind of silly. All right. You come up to the counter with zero money. What are they going to give you?
Zero money.
Zero monies, like 0 euros. I like it. So then that leads right into 29. Which of these is a more direct model of what's happening? Is this direct variation?
Yes.
Why?
It's a constant rate. There's no plus.
True. But more importantly, what point does it go through?
No, it points from 0, 0.
Good. I like it. I like it. So that's direct variation. Now listen. I really want you to understand. This is actually kind of a silly question, because if B is 0, then that becomes this form, right? If B is 0, don't these two have the same form then? Yes. Do you guys see that? So in reality, it's all this, but they're just trying to make sure you understand that since B is 0, I'm really going to use this guy. So why am I going to use this guy? Because it's direct variation. It goes through the point 0, 0. So B would be 0. Okay, let me stop for a minute. These aren't huge deals. They really aren't. Now, there were some problems in the homework where you had to do this. Now, notice this. Do you see how it says $20 exchanged for 18.16 euros? So I don't know the direct constant multiplier. I don't. But let me ask you this. No, stay with me. I want an equation that gives me the number of euros based on the number of dollars. So which one of these, euros or dollars, will be X in my equation? Which one will be represented by X? Think about it. So I want the equation to give me the euros based on the number of dollars. So what does based on dollars means? It means if I do some shit to the number of dollars, I will get the number of euros.
Yeah, so you divide.
Wait, don't go too far. Which one's Y, which one's X? Is the euros Y or X? Is the dollars Y or X?
Euros is Y.
Euros is Y. I love it. Because then that would equal something times dollars. So I will get euros when I input dollars. Now, how do I solve for K? How do I get what K is? Do I know what Y and X are in some situation?
Yeah, you may say it?
Yes, good.
Divide the euros by dollars.
No.
Right? 18.
Yes, sorry. Yes.
18.
All right, try to catch up to you. So if we put it in, you're right. So if you put it into the equation, right? So the number of dollars is X. So $20 gives me 1816 euros. Does everybody see what's happening? So this is why it's important to decide which variable represents what idea, right? So now we'll do exactly like Vu said, divide by 20. All right, can somebody do that for me? Don't round it. It should just come out to 3 places, right?
0.908.
I love it. Now, you ready for this next question? This isn't even part of the question. Can somebody tell me what the units are on this? Consider what we just did to get it. What are the units? Something per something. What are these? What are these right here? What's 1816? 1816 what?
Euros.
Euros. So this is euros per
Dollar.
dollar. I like it. And of course, we know this already, considering where K is. What is K? What would we call K? K is the what of this line?
The slope.
Slope. All right. So now if I put this all together, I get y equals 0.908 x. Now watch this real quick. Just one other thing. Remind me what y meant. Y means euros, right? So wouldn't it make a little more sense to actually call this equation E equals 0.908 D, right? Euros and dollars. Do you guys see what I'm saying? Y and X are called dummy variables. They are placeholders. They're the most basic choice of symbol for the placeholders. Do I have to use them? Shit, no, right? I could use symbols that make more sense related to what they represent. So I don't have to keep going back. What was Y again? What was X? Oh shit, no. If I put E and D, I know that's euros and I know that's dollars. Mm-hmm. Nothing wrong with that. All right, now go ahead and do number 31. That should be relatively quick. So this is what you get for this one. No, yes, maybe. No, yes, maybe. Some of you guys are looking at me like I'm crazy.
Shows like it's 0.45.
Yes. Yes.
0.45. What?
What?
You add an additional 1816.
Oh,
yeah,
okay.
I like it. So Linnell
okay,
noticed something. So I could either do this.
You add it.
I mean, I can use my equation, right? If I put the dollars here, so I'll put 40 here. So what's 0.908 times 40? It's this. But then Linnell said, I could just add that because every time it goes up by 20, every time I go up by 20, my euros go up by 1816.
1816, yeah.
Yeah, so the quicker way, and that sounds like a history test, but every time, what happened in 1816? All right. Now, I could just add 1816. Now, I really want you to understand the connection here. So if I add 1816 to this, I will get 54.48. Can you double check that? What is 0.908 times 60? Yes, I like it. Thank you, Lino. That's the power of the slope, right? The slope is awesome. Linear functions are awesome. And this is the first way we used linear functions was adding the same amount each time instead of multiplying like exponential does, right? So we're just bringing this all back together. If I have the equation, I could just plug the point in, but what I'm really doing is just adding the right number of these. Now, what if I put, now see, these are simple now, but what if I put 103.92? Can I do what I'm doing here to get 103.92? Oh shit. So that's when I need to use this guy, right? I could do y equals 0.908 times 103.92. Then that'll just eat it all up. But if the steps are nice, I can directly apply the slope. Is everybody with me? So that's why both doing this and doing this work. So why do we have both ways? Because I might get this thing, holy shit, and then I can't do it this nice steppy way. I have to do it the equation way. I like it. Hey, Mikey. All right. So everybody got everything from that. Well, let's do this one last one. You guys can see this, 32. Just use your equation real quick. What would you get for 500 bucks? Use the equation, right? Don't grow the chart. Don't do that. That'll take a while to get to 500. I think it's 454. What do you guys get out there?
€454.
Good. I like it. All right. What if I exchange the other way? What if I am a European and I have 1,052 euros? How many dollars would I get for that?
You want the answer?
Yeah, let me set it up real quick so everybody can catch up. So obviously this will go here, right? That's the euros. And then what'd you do, Vu?
I divided 1,052 by 0.908.
I like it. All right, and then what'd you get? 105 point something.
1,158 and 59 cents.
1,000, sorry, 58?
1,158
Oh, 1,158.
and 59 cents.
59 cents, that's right. Don't forget my cents. I like it. All right, so nothing major there. That's the power of setting up an equation. It becomes just solving an equation to get the answer. All right, wow, look at all that work. Jeez, that's a big mess.
So when you say show your work, do you want it to look like that?
Yes.
Like that whole page?
Yeah, for each, no, look, no. Some of this is notes, right? Like this was a note. So this isn't like, you don't have to show every single thing I've done up here, but you'd have to show enough.
Yeah, I was being a jackass.
I know. All right. How's everybody else? I'm going to clear that page now. It's all going to go away. Here it goes. It's gone. Okay. Now, try these two, 33 and 34. All right, let's see. Let me catch up to you guys. So they charge $50 for a house call. And then once they're at your house, they charge $30 for an hour of labor. So the reason this works in the real world is if I call them to my house and when they get there, something happens and I can't let them inside and I got to go and all this stuff, I'm still going to have to pay them $50 for coming. Too damn bad. So can somebody identify for me which one of those things is the slope? Remember, slope is a rate of change. Go ahead, say again. Sorry.
30.
30. I love it. And again, this doesn't always show up, so be careful about this, but that per is a huge giveaway. $30 per hour. So it's dollars per hour, and slope is a ratio. So that kind of points to that being a good candidate to be the slope. So $30 is the one that depends on the other variable, which will be time. Good Lord, Jeff. Let's try to write. We could do this. We could do this. Let's show off our writing ability. Here we go. 30. Good job, buddy. What's the y-intercept going to be? Which means what goes here for a y-intercept?
50.
No. Careful.
Zero.
I mean, right there. What goes here? 0. Always 0, right? The beginning of a y-intercept. And then comes 50. So in the context of this problem, if he stays 0 hours, I still have to pay $50. So then I just take like 7 seconds and write the equation of the line. Write the equation that models this. I'm sure somebody's already done that. So what's the equation?
30H plus 50.
I like it. And so what you've done was what I'm about to say. You could actually use better letters for this. We could use cost equals 30 times H, yeah, number of hours. I love it. These two mean the same exact thing. The variable I use has to be consistent, but it doesn't have to be a specific symbol. And this makes sense because it lines up with cost and hours. I love it. Now, here's something we haven't done much of. I want to show you this. This is kind of cool. The one point I know this goes through is the point 0, 50. Can you guys graph that real quick on number 34? Can you graph 0, 50? So I'll be right there, right? That's 0, 50. Now this is, now let's see if you guys, all right, this is, I'm going to try to bypass making a table. What does this mean? That means that every what, the what goes up by what?
Every hour it goes up by 30.
Yeah, every hour it goes up by $30, right? And notice, no, just stay with me. This might not be the best problem to try to do this on, Stay with me now. So 2 hours, how much would it go up by?
60.
60. I love it. So try this. In 5 hours, how much would it go up by?
150.
150. I love it. So in 5 hours, then watch. Why am I doing that? Because it does 30 fit on the scale nice. The scale they've chosen here, just no, 30 sucks. 60 sucks. But 150, I can do that. So 5 hours, if I go over 5 hours, I would go up 150. 50, 100, 150. Now let's see if that matches up if I try to do these little intermediate steps. Every hour, it goes up by 30. Every hour, oh shit, here we go. It goes up by 30. Every hour, it goes up by 30. Every hour, it goes up by 30. Yes, okay. Oh, I can do, come on, Jeff. You know better. Let me do my magic here. Wow, wow, wow.
There we go.
That's fine. All right. That's almost right. Okay. Anyway, that's pretty close. Chip, chip. So that's the thing. If the slope is $30 every hour, that's the slope here, right? That means it's also $60 every 2 hours. It's also $150 every 5 hours. So it's kind of like the idea of if I take steps, I could take small steps or I could take big steps, right? But I'm going to still get to the same line. So if I take a small step, or if I take 2 small steps, or if I take 5 small steps, it's the same as taking 1 big ass step. I don't know if that made any sense. Okay, hopefully. So I could actually graph the equation line just knowing the y-intercept and the slope. Y-intercept tells me where to start, and the slope tells me how to move from there. How to move. Okay, maybe. Let's verify what we just did. Why not? Let's make a table of values. Yeah, get out of my way. Go away. So what about if it's, so 0 is 50. We knew that already. What's 1? What would I get if I put 1 hour in there?
80.
80. I love it, right? 1 times 30 plus 50. 2. So 2 times 30 plus 50.
110.
110. And again, you can see the shortcut here is just to add 30 each time, right? So if I keep doing that, add 30. Keep doing that, add 30. Keep doing that, add, hey, there's 5, 200. That's the point right there. That's 5, 200. There it is. Sweet. All right. We are analyzing the hell out of these things. It's crazy. You guys are all probably going a little insane. I understand. I'm going to clear this. Is anybody still copying some of this craziness down? All right, here it goes. Bye, work. Okay. Yeah. I don't know if I've said this phrase yet. I might as well say it now. Somebody remind me in this equation real quick. This is going to be real simple. What is that? What's that represent?
Slope.
Slope. I love it. Remember, it's like from the French word marcher is what they think it might be. And then what's that represent?
Y.
Yeah, the y piece of the y-intercept. I love it. So guess what we call this? Because math people are so creative. We call the equation right here, we call it the slope-intercept equation. Because it's got the slope and it's got the intercept in it. So let's call it slope-intercept. So when you see them say slope-intercept, they mean this form. because we will be talking about a different form maybe today. We'll see. So go ahead and do number 35. Create that equation real quick. Which one of, so I really want you guys, I want to make sure everybody's looking at this correctly. I need to figure out what the value of this is, and I need to figure out what the value of that is. Which one of those do I already know without doing any work? Do I know the slope, or do I know the y piece of the y-intercept?
Y.
Yeah, what is it?
3,600 or 1,000.
Yeah, because when the input is 0, the output is 36,000. So I know that that's 36,000. So now I can focus my attention on what the hell is the slope, right? So I'll give you just another few seconds to figure out what the slope is. All right, let's see. Does anyone think they have the answer for the slope?
5.
Be careful. So I see where the 5 came from. So the minutes changed by 5, but the slope is a ratio of how much the outputs change over how much the inputs change. So how much is this change?
Negative 7,500.
Good, negative 7,500. And this changed by 5. So remember, the slope is the change in y over the change. I don't know if I've used that symbol before, but that means change. How much do the y's, how much do the outputs change? Negative 7,500, while the inputs change by 5. So this really tells me how much do the y's step while the x's step by how much. That's all that means. So the y step down by 7,500 while the x's step up by 5. So it's a ratio of those. We know the slope is a ratio. We know it's a rate. So then what do you get when you divide that?
Negative 1,500.
Good. So that'll go right there. How do I check this? What am I supposed to get when I put a 10 into the equation? What am I supposed to get if it's the right equation?
21,000.
Yeah, I'm supposed to get 21,000. So if I put a 10 in, let's see what we get. We get negative 15,000, and then one more 0. So 15,000 plus 36,000, sure enough, is 21,000. Check. Do you guys see that? The equation is supposed to capture all the points this line goes through. So how do you check any equation that you get? Put a point in, make sure it works. Okay, maybe. All right, so I want to do a direct problem with you. These are kind of like dancing around a few things. And I want to remind you, I think I've shown you this equation before for slope, where it's, have I shown you this before? Y2 minus Y1 over X2 minus X1. Does that look familiar to anybody?
Yes.
So, and look how it makes sense. Didn't I subtract these two, which is y2 minus y1? And then I divided by the difference between these two, x2 minus x1. So the little 2's mean the second point, and the little 1's mean the first point. All right, so I want to do a fresh problem with you, a direct algebraic problem. No, not even a wordy problem. So I'm gonna clear all this away in a minute. I think some people are still copying down. Who's that? Do I know this person? Let me see. Interesting. All right. So everybody finished copying those? I think so. Let me check one thing real quick, guys. Hold on. I don't have a clue who that is. All right.
Sorry, that's me. I'm trying to switch screens, but it's like not letting me.
Oh, okay.
Sorry.
Thank you.
Okay.
All of us teachers are kind of a little paranoid about Zoom bombers. All right, let me clear this. Let me find some free space here. Here we go. I'm going to do a problem right here, unrelated to everything around it. So let me just put a big old box around it. Wow. So what have I said? Find the equation of the line that goes through the points 4, -1 and 0. What do you got, Jeff? 7. Sure, I like it. So I know the equation of a line is y equals mx plus b, which always means I have two things to find. I have to find the slope, and I have to find the y-intercept. Is everybody with me? Do I know the y-intercept? Do I know the y-intercept for this problem?
Yeah, 0, 7.
Yeah, 0, 7. So what's the value of b?
7's
7, done, right? So all b is the y piece of the y-intercept, right? That's all b is. How do I find the slope? Right, so let's see here. What's the y in this? The y is 7 minus, what's the y in this? -1. So what I'm seeing is, how did I get from this point to this point, right? Y was -1, now it's 7. So I want to see what that change is. That's what this means. One y minus the other y. So how much did the y's change? That's going to be how much it rises or falls, divided by how much did the x change. So it's 0 minus 4. Let me stop for a minute. That's exactly what we've been doing. In fact, let me write it in a different way for you real quick. Let me write it the way we've seen it. So here's, what do we got here, Jeff? Let me try to keep this the same way. So here's 1.4 -1. Here's another point, 0, 7. So how much did this change from -1 to 7? How much is that changing? Does it go up or down?
8.
How much did it, sorry?
By 8.
8. And then how much did this change?
-4.
Down 4. I love it. I mean, that's what we've been doing, right? But isn't that, look, what do I get here? What's 7 minus -1? 8. And what's 0 minus 4? Negative 4. It's the same exact work. I just don't have to write it like this. I don't have to write it like that. I can just use this equation. Do the difference in the y's divided by the difference in the x's. And of course, what's that? What's 8 divided by negative 4?
Your slope's -2.
Negative 2. I like it. So now I've got everything I need. I've got m and I've got b. So now I can just throw it all together. Y equals negative 2x plus 7. Kabam. How do I check that? How do I check it to make sure it's right? Well, what's supposed to happen when I throw a 4 in? What's supposed to come out? Are you guys all right? You guys doing all right out there? We'll do another problem like this. Don't worry. We'll do another one. When I put a 4 in, what's the output supposed to be?
15.
-1. No. So looking at the point, I know the output is supposed to be -1. And sure enough, what is negative 2 times 4? -8. What's -8 plus 7? -1. You guys are hating this. All right. Let's do another problem. This now this down here, this is me checking my work. This is the answer right there, but I can always check it. What is this equation supposed to do? When I find the equation of a line, what is it supposed to do? It's supposed to capture all the points. It's supposed to go through all the points. What does that mean? All the points are supposed to work in it. That's what that means. So I can check it by plugging a point in and making sure it works. All right, let's do another one. I'm going to clear this away. Let me know if you're still copying down. All right, here he goes. It's gone. Bam. All right, here we go. Let's do another one. Dadgummit. Technology. All right. Let me paraphrase here. Find equation of the line. Oh my gosh, Jeff. Going through, what do you got, buddy? 0, -5, and let's see. What about, yeah, 16. Ooh, I like it already. 16 and it doesn't really matter. Yeah, let's just make this gross. Yeah, I like it. So I know I need 2 things, right? I need the slope, right? I need M, and I need the y-intercept so I can get what B is. Do we know the y-intercept? Do we know the y-intercept?
-5.
Yeah, 0, -5 is the y-intercept. So we know it. So B is the y piece. So we know B, kick ass. All I need now is M. I'm going to shut up for a minute. You guys figure out what M is. It's going to be slightly gross. It doesn't matter. Oh, I know. We're going to do one more after this, just because I want to show you one that's got real life implications. So all the little 2 and the little 1 means is the second y minus the first y. So on the top, I would put 7 minus -5. So it's just subtracting the 2 y's. I want to see how much did it go up or down. I want to see how different are the y pieces. Divided by 16 minus 0. So obviously the x went up by 16. What's 7 minus -5?
12.
12. And of course, 16 minus 0 is 16. And then how do you reduce this?
Three-fourths of points. Your slope is 0.75.
3/4. Let's use 3/4. So then the equation is going to be m, which is 3/4, times x plus, well, it's actually minus, since it's a -5. Dip. So if I want to check this, that's the answer. That's our answer. If I want to check it, if I put a 16 in, I'm supposed to get a 7 out. So let me put a 16 in. 4 goes into 16 4 times. 4 times 3 is 12. 12 minus 5 is 7. Check. I got the 7. That's a weird looking 7. Oh, well. Everything you write is weird looking, Jeff. I know. I don't know if, do you guys get that check? Because again, the equation of a line, what does it do? It's supposed to go through all the points. Each point it goes through works in the equation. That's what it means. All right, let me do one more. Does anyone bake? Anybody ever bake anything? Some of you guys? All right. Anybody ever looked at a thermometer? All right. So what system of measurement do we use for temperature here in the US?
Fahrenheit.
Fahrenheit's crazy. What does most of the rest of the world use?
Celsius.
Celsius, kick ass. I'm going to clear all this away. Is that all right? Anybody still copying this down? Oh, somebody is. You're not speaking up. Here it goes. It's going away. Say bye-bye. Bye. Okay. Now, somebody help me out. Does anyone know? I know we live in San Diego. So you're like, why would I know this? But let me see. Let me do it this way. Yeah. Celsius, Fahrenheit. What's the freezing point? What is it in Fahrenheit? Sorry?
32 degrees.
32 for Fahrenheit. What is it for Celsius?
I don't know.
0. Celsius is like metric. 0 is freezing for water and 100 is boiling for water. So boiling. Now here's where I need my bakers or my cooks or something. Does anyone know what boiling is for Fahrenheit for pure water? Anybody? All right, we're all going to learn something together. It's 212. 212 degrees, if I have pure water with no contaminants or salt or anything, 212 degrees, it'll boil. All right, I like it. Is everybody with me? So I've got 2 points here, don't I? 0, 32, and 100, 212. So if I make an equation of a line for this, it will be a conversion between Celsius and Fahrenheit. So when your Canadian friend says, it's hot outside, it's like 27 degrees. You go, oh, okay. You mean Celsius, all right. So what's kind of nice about this? Do I know my y-intercept? What's B?
0, 32.
Yeah, so the y-intercept is 0.32, check. So B is going to be the y piece 32. I like it. So we got the B part, check. Now take a minute and figure out the slope. It's going to be a fraction. Don't freak out. Just reduce it. I think these equations came up earlier this semester in the book when we did the conversions, yeah. But now we're going to prove it. We're going to prove the equation. Some of you guys are like, I didn't ever need to prove that equation. Too bad. We're doing it. Too bad. Yikes. Oh, Jeff, what are you doing with the twos, dude? You can only have 1 second point, dude. Are you kidding me? So what goes on the top here of the slope? What goes up here? Man, you guys are
212
like,
minus 32.
thank you. Is that all right? It's the second y minus the first y. It's how much did these change? That's exactly what we've been doing for a long time to figure out rate of change, to figure out slope. And on the bottom is going to be the second x minus the first x. So I get 180 over 10. I'm sorry, 100. And then how does that reduce? Right, I can divide by 10. That's nice.
9 over 5.
Yeah, 9 over 5. So I don't know if this, so let me write it this way and then I'll write it better. So y equals slope x plus b. But let's do it like this. What does y really mean in this problem? Can somebody see? What does y mean? What's the y pieces referencing? Fahrenheit or Celsius?
The freezing point of Celsius or Fahrenheit, sorry.
Well, it's not, I got freezing and boiling, but this is the Fahrenheit. Yeah, so that'll be Fahrenheit equals 9/5. And of course, x must be Celsius plus 32. So if somebody in Canada, I'm picking on Canada because it's right there and it's another country, so they're reasonable and they use a scale that makes sense. Not like us Americans. And they say, oh man, it's 20 out today. Can you convert that to Fahrenheit for me, please? So they say it's 20 degrees Celsius. What would an American say that is? American. Right? All you have to do is put a 20 in for Celsius. And this is nice. 5 goes into 20. 5 goes into 20 4 times. So you get 36 plus 32 is 68. So if somebody in Canada or somewhere else, almost every other country said it's 20 degrees out, that means 68 degrees Fahrenheit. Here's an interesting little side note. If it's negative 40 degrees Fahrenheit, it's also negative 40 degrees Celsius. That's where they both, and you could check it. You could plug negative 40 in for Celsius and see what you get. Let me see if I'm remembering this correctly. Yes, I like it. Right. You're all like, wow, Jeff, that's exciting, dude. Thank you so much. I'm sorry. It's just an interesting little side note. Does anyone know a third temperature scale besides Celsius and Fahrenheit? Does anyone know there's a third one? Oh, I got a chat. Dude, I'm excited. Dude, yes, Kelvin. Good old Lord Kelvin. Anybody ever heard of absolute? Go ahead, sorry.
Isn't calories a measurement of heat?
Calories is sort of a measurement of energy.
Okay.
Yeah, they do involve the amount of heat required to do something, but it's not really a measurement of temperature like Celsius and Fahrenheit are. Has anybody ever heard of absolute zero? No? You're all like, dude, we're living in the absolute zero year. I agree. That could be a nickname for 2020. Absolute zero means no energy left. What is when it freezes, can it not get any colder? If it freezes, can it get colder?
Of course.
Of course it can. In fact, just talk to anybody who lives up in Minnesota. Minnesota, it's a warm day. It's like -5 out here. All right, that's not Minnesota, Jeff. I have no idea. That's a New Yorker that moved to Minnesota and then has some weird in-between accent. I have no idea. Now, absolute zero on Kelvin. If it's 0 Kelvin, that means that is the cold. There's no energy is what that means. Everybody's dead, right? When you hit absolute zero. That's exciting, Jeff. So it's just a happy message to bring for you. All right. I think I'm going to call it. You guys seem a little out of it. I think that's fine. Let's call that there. And then tomorrow we'll get into the next section. Tomorrow we're going to deal with, what if I don't know the y-intercept? Is there still a way to do this work? And the answer, of course, is yes. Math people always making up new shit. That's what we do.
Wait, I'm confused. I thought tomorrow you were not having class.
Oh, not tomorrow. You know what I mean. All right. I'm glad you said
okay.
that. When I always say tomorrow, and I mean the next time I see you. So the actual tomorrow, there's no class. So just remember that. I got a meeting like with the state senate. So I'm going to be there. No, I'm going to be here, Zooming there. So on Monday, we'll keep going.
I have a question. Do you have office hours tomorrow?
I do. So the meeting is
Okay.
in the morning and they'll be done in time for my 2 o'clock office hours tomorrow. Yes.
Okay.
Sweet. Next Thursday, I might be out all day. In fact, I probably will be out all day. So I'll just have to remind you guys, next Thursday, a week from this Thursday, there won't be any class or office hours. I'll be out all day. It'll be exciting.
Okay. Thank you.
You're welcome. Anybody need to hang out? You guys are good? I'm going to stop sharing. Bow. Let me know if you got questions, if you got to hang out. Otherwise, go get some sleep or something. All right. I'm out of here. I'll see you guys.